This is an example of how to use the chi-square goodness of fit analysis in SPSS. I'm going to use an example of two pieces of data that might be used at Denison, say by the first year student office. And in this case, we have two questions. Did you attend a pre-orientation trip? Yes or no? And do you consider yourself to be flourishing at Denison at the end of your first year? Yes or no? If we were to look at both of these variables together, we would be choosing a chi-square test of independence, or a Pearson chi-square. If we look at just one variable, then we're choosing a goodness of fit test. Some people will call this a one-sample chi-square test, for example. So let's take this with just the variable of flourishing. And let's ask ourselves, are students at Denison more likely to be flourishing than not flourishing? Or are they equally likely to be flourishing or not flourishing? So let's just ask this question. With Analyze, we're going to the non-parametric test for the goodness of fit. So non-parametric tests, then we're going to a strange place called Legacy Dialogues, and this is where we'll find the chi-square. So once we find the chi-square, we're asked to test a variable. We chose flourishing. We only need one variable here because we're simply comparing the likelihood of choosing yes to the likelihood of choosing no within this variable. We can ask for a lot of descriptive statistics. We don't really need them. And now under expected values, here we're going to consider all categories equal. But this is a cool thing about the chi-square test of goodness of fit, is that you could choose values. For example, you want to say, are students more or less likely than 30% to choose flourishing, or 70%? So if there's some sort of benchmark that you want to compare to, you can simply list that here. In our case, we just want to know whether they're equally likely to flourish or not. And so we're going to consider all categories equal. Okay, I don't have very much to look at here, so it will be a pretty quick analysis. What I see is that I have a total of 60 people. 36 said, no, I'm not flourishing. 24 said, yes, I am flourishing. Notice here that if we consider all things equal, we would expect an equivalent group of 30 and 30. So we want to know, statistically, how likely is it that we would get this different of a proportion if the actual difference is roughly equivalent, 30 and 30. What we see here is a chi-square value of 2.4, degrees of freedom of 1 because we only have two groups, and a significance, asymptomatic significance, here's what we see is 0.121. What we are looking for is that significance or probability level below 0.05? In this case, it is not. So 0.12 is higher than 0.05, which means that we're outside of that region of rejection, which also means that when we look at yeses and nos for the flourishing question, we don't have enough evidence to suggest that we reject the null hypothesis, meaning that we can't say that significantly more students are flourishing than not at Denison. Remember again, this is all fictional data, so this is not based on any fact, but you might imagine if you were the first year office, what would you do with this information? Would this be positive information, negative information? How could you use this kind of an analysis to keep track of how first year students are doing from year to year and how they're responding to your programming?